Hey guys, how's everything going? Today, let's take a look at sort. There are a lot of sorting algorithm, and I'm just using this line 1, 2 to do the experiment. So the first method we're gonna take a look at is bubble sort. Bubble sort, as the name says, we're trying to compare the adjacent nodes every time, and if this element is bigger than the next one, we just swap the position and then check that element again and swap it if it is necessary. So we are expected to move the biggest number to the end, right? And then we could do it over and over again, and because the biggest one is moved to the end, and we could ignore that in the next round. And so every round will reduce the total amount by 1. So after n round of traversal, we could generate the sorted array. Here is a image showing this that. So every time, wait a minute, I reload it. So every time we compare the adjacent nodes, if it is bigger, then we swap it the position. See that the biggest one will be moved to the end, right? So that is fixed. We can ignore that, and then from the beginning, do it over and over again. Yeah, and that by that we could get to the result. What's the time complexity? It's obvious that there will be n round for each round. There will be not exact n, but in a big O notation, it's n. So the time complexity will be n squared. Well, for the best case, if it's already sorted, it means there will be no need to do the swapping, right? We could keep a flag, say, did we swap any nodes or not? And if not, it means it's already sorted, so we could ignore the rest checks. So that will be linear time. We just check we could do that by one pass. So worse, basically, it's n square. The best case, n linear. What about space? We do the swapping, so there's no extra space, so the space complexity is constant. Okay, so let's. First one is bubble sort. A time would be n square. For best case, linear time. Space constant. So let's do it. I will first create a util function called swap ij. Okay, for now we will loop through the nodes from left to right, right? And the ending will be different for each round. So we will say let ji equals the last one. We will compare the node to the next one. So for the first round, I should end at here, and then end at here, and then at here, right? So let I equals nums.length minus 2. I is bigger than 0. I minus minus. For let j equals 0. Now we could start the comparison like this. Start from the first node, and then j would stop at J. Is this right? Yeah. J's plus plus. And then if nums j is bigger than nums I, no, j plus 1. This is minus 1, this is minus 2. Yeah, so minus 2 plus 1 is minus 1. Okay. If it's bigger than it, then we swap j plus 1. And finally, we return the nums. You see that we only swap it when this one is strictly larger than next one. So for 1, 1, we don't change the position. So these bubble sort, it's stable, which means these two ones will have the same positions. We don't touch them. Okay, let's run the code. Yeah, I think it worked, but it might not be that fast. Yeah, you see, we only are faster than 6% of all the submissions. Well, which will improve in other videos about different sorting algorithms. About the best case, so how we could improve it for the best case? Well, we could keep a flag like let is swapped false. And if we swap something, we set it to true. And for the first round, right? For the first round, we will stop at any round, right? Any round if there is no swap occurred. So for each round, if isn't swapped, we just break, right? It means already sorted. Cool. Let's run the code. Wrong answer. Wait a second. Uh-oh. God. The initial value should be true. It's swapped so we can continue. Yeah, let's submit. Cool. It might be improved a little bit based on the input. So let's recap on these bubble sort. A time and square. The best case we use linear time. A space, constant. It is stable. Okay, so that's all for these bubble sort. Stay tuned for next video, and bye-bye.